Hey, welcome to The Explainer. We're here to break down the big, complex topics that are really shaping our world.
All right, let's just jump right in with a number that really tells the whole story. A 200% increase in the wait time for critical power transformers. I mean, think about that. What used to take months to get now takes years. And it's putting the brakes on everything from new solar farms to the AI revolution itself.
So, here's how we're going to break it all down in this explainer. First, we'll look at the shortage itself, what's happening on the ground. Then, we'll dig into what's driving it. Compare the two different manufacturing systems emerging globally, see how this is all pushing a tech revolution for AI, and then we'll wrap up with a clear strategic outlook.
Okay, let's start with the heart of the matter, the great transformer shortage. We're talking about a foundational, absolutely essential component of our global electrical grid. And right now, there just aren't enough to go around.
So why is this happening? Well, to put it bluntly, our electrical grids are at a breaking point. I mean, think about it. Most of the grid in North America and Europe was built decades and decades ago. That hardware was only designed to last 30 or 40 years. And guess what? Time's up. We're now facing a massive, urgent, and global replacement cycle all at once.
And of course, this has a huge economic fallout. It's just basic supply and demand, right? When supply is this tight, prices go through the roof. Just look at this. Transmission transformers, the really big ones, have seen a staggering 21% annualized price increase. This isn't just a minor headache, it's a major cost barrier for the entire energy industry.
So what's behind all this? Well, it's not just one thing. It's really a perfect storm. A combination of insane demand and some very real, very structural problems on the supply side. You can really boil it down to three core drivers. First up, you've got the insane power demands from AI data centers. They're creating what the industry calls a suction effect, just pulling all the available transformers right out of the supply chain. Second, as we just talked about, is that massive grid replacement cycle happening in the West. And third, we have major bottlenecks in the raw materials needed to even build these things.
Now this slide is super interesting because it shows you exactly what we mean by that AI effect. On the left, you've got today's setup, but look at the future on the right. Data centers are becoming so power hungry, they're no longer just plugging into the grid. They need their own dedicated substations. They're becoming what we call hub-level consumers.
Okay, and this gets us to a major choke point. It's a material called GOES, or grain-oriented electrical steel. This isn't just regular steel, it's the secret sauce that makes a transformer core efficient. And here's the problem. It's incredibly difficult to make. To give you some perspective, the entire domestic capacity of the US can only meet about 20% of its own needs. That's a huge dependency.
You know, this whole supply crisis has exposed something really big. A huge difference in manufacturing power around the world. It's really become a tale of two competing systems.
Okay, check this out. On the left, you've got your Western incumbents. They're working with older factories, their supply chains are all over the place, and lead times, we're talking more than 2 years. It's crazy. Now look at the right. Chinese challengers are using modern, high-volume factories with vertically integrated supply chains. Their lead times? Less than 6 months. That is an absolute game changer.
And this table just drives that point home. Look at the growth forecasts for the big, established players. Pretty modest, right? Now, while we don't see a specific number for a challenger like Minyang Electric, the entire market context implies they're seeing sky-high growth by just hoovering up all this unmet demand.
And the real-world impact of that speed and efficiency? It's right here. A 36% surge in China's transformer exports last year. That is a huge number. They're not just meeting their own demand. They're actively filling these critical supply gaps in markets all over the world, including North America.
All right, so all this pressure, this crisis, it's actually forcing a massive technological leap forward. It's that old saying, right? Necessity is the mother of invention. And that's especially true when we talk about powering the future of AI.
So this raises a massive question, especially for the big tech players like NVIDIA. How in the world are you going to power a single server rack that pulls down 1 megawatt of electricity? The old ways just aren't going to cut it. You need a totally new solution.
And the answer might just be something called the solid-state transformer, or SST. Now, this is a total game changer. Forget those huge, heavy coils of copper and steel. We're talking about using advanced semiconductors, like the chips in your phone, to convert voltages. It's basically taking 100-year-old analog technology and making it digital and smart.
And just look at how much better it is. This slide lays it all out. The traditional methods have all these extra steps, all this wasted energy. But the SST solution at the bottom, it's a straight shot. It's way more efficient at 98.3%, and it's so much smaller.
For a huge data center, this means saving millions, literally millions of dollars in energy and real estate costs every single year.
And listen, this isn't some sci-fi concept for 2050. This is happening right now. The timeline is speeding up. We've got Google already presenting its new architecture, Vertiv is launching its portfolio in 2026, and the big one, NVIDIA is planning to roll this out for its next-gen Rubin Ultra platform as soon as 2027. The race is on.
Okay, so we've covered a lot of ground. The shortage, what's driving it, the big manufacturing shift, and the new tech. So what does it all mean? What are the big strategic takeaways here?
I think it boils down to 4 really crucial points. 1. This transformer shortage isn't a small problem. It's a massive, systemic risk to both the energy transition and the AI buildout. 2. AI is the catalyst. It's the single biggest factor shaking up this market. 3. Power is shifting east, and that creates a huge strategic risk for the West. And finally, 4. This crisis is forcing us to leapfrog to a whole new generation of technology, which could rewrite all the rules.
And that brings us to the core idea here. The future of AI isn't just about faster chips or smarter code. It is fundamentally 100% about power. And the race to control that power? Well, as we've seen, it's already started.
So I'll leave you with this final thought. We have all this amazing technology racing ahead, changing everything. But is the very foundation of our modern world, our electrical grid, ready for it? Is it an enabler for innovation, or is it actually the single biggest anchor holding our future back?
If you want to go deeper on this topic, the analysis we've been walking through comes from the folks at HDNN Research.